What's up, everybody? It's Coach Sharf. Welcome back to my Algebra 2 Notes videos. And today we are going to talk about inverse functions. First things first, if you're seeing this in real time, it is Sunday the 14th. I'm getting this up. I was going to try to get it up on Friday, but didn't have a chance to get it up till today. I had some stuff going on, so I apologize for that. And you gotta quit hitting the table because it's making a bounce too. But we're doing the inverse function video, so I'm gonna start with this video. It's gonna have the basically kind of talk about what inverse functions are, and I'm gonna do 3 examples. I'm gonna do them both ways, so we've discussed. I'm gonna try to make it as quick as possible. We'll see how the time is. I'll do a few more videos, like I said in class. I'll probably post the video I did last year too. Maybe I'll find a way to trim it first before I post it, so it's not a whole hour long. But anyway, let's go ahead and get started. So let me share my screen and we'll begin. All right, inverse functions. So I asked y'all when we started this, what does inverse mean? Inverse means opposite. So we're trying to find 2 functions that are opposite of each other. What does it mean for them to be opposite? Well, it's a lot of things. All the operations you're performing in your original function, you have to do the opposite in the inverse function. And the real definition, we do that to actually achieve the real definition, which is all my x's I plug into my original function, I get a y value for them. My inverse function, those should be flipped. So I take whatever those y's were, plug them into my inverse function, and I should get my original x. Okay. So given a function f of x, my head out of the way, I need to find the opposite function that flips my inputs and outputs. Again, my x's and y's, my inputs are my x's, what I plug in, put in to my equation. My outputs are what I get out. It really should be out gets, get out. Yeah. Anyway, outputs are my y's. The inverse functions are shown with the notation f negative 1 of x. Again, it looks like a exponent of negative 1, but I'm not calculating anything. It's just why I stick on my regular function notation to designate that it's an inverse function. So again, flipping inputs and outputs, to try to explain a little better here. So you can pause that if you want to get it down. Again, I'm just trying to get to the meat of everything. So if I plug in 3 for x into my original function and I get out 8 as my answer. So I plug in 3, get out 8. I have to find a function that when I can flip that. If I plug in 8, I get out 3. So original, plug in 3, get out 8. Inverse, plug in 8, get out 3. But the catch is it has to work for all pairs. The catch is it has to work for all pairs. So if y'all didn't get this and you still want to write it down again, this is really just explanation. Y'all can pause right now, but I'm going to go ahead and move on. So example, I think I flipped this in maybe 5th or 6th period on Friday. So slightly different than if you'd seen it in class. This was x divided by 2 plus 1 instead of minus 1. I was really trying to more get it to match what we did on the previous slide. So here, if I plug in 3 for x, in my original function, x plus 5, if I plug in 3, I'm going to get 8. 3 plus 5 is 8. We're trying to see if x divided by 2 minus 1 is my inverse function for this. So I plugged in 3, got 8. Now if I plug in 8 here, 8 divided by 2 is 4. 4 minus 1 is 3. So plug in 3, get out 8. Plug in 8, get out 3. Checks out for that pair. But let's try another number. We're going to go a lot bigger here. Let's go 45. If I plug in 45, 45 plus 5 is 50. So now if I try to plug 50 into, that's not good looking 50. Try to plug 50 into here. 50 divided by 2 is 25. Minus 1 is 24. So that did not work. I plugged in 45, got 50. Plugged in 50, I did not get 45. I got 24. So move my head real quick. This is not the inverse. And it's not the inverse. Has to work for all pairs. So the ultimate point of this, again, I'm trying to talk, I'm trying to explain it really quickly and in a, I don't want to say theoretical sense, but what we almost did here, we were just picking two random equations. We happened to find one pair of numbers that worked. The second one did it. Again, you can use a whole bunch of different things. If I use 12, 12 plus 5 is 17. 17 divided by 2 is 8.5. Minus 1 is 7.5. So I got 12, 17, 17, or 12, 17, 17, 8.5. Didn't work. Or 17, 7.5. I'm sorry, didn't work. I could take, if I said my original function was x plus 5 and I pick, if I plug in 3, get 8. I could find an infinite number of functions that I could do the opposite, plug in 8 and get 3. So this is an example. I could do 8x minus, plug in 8 and get 3. So 8x minus 61. 8 times 8 is 64. 64 minus 61 is 3. I could do the square root of 2x minus 1. Plug in 8 here. 2 times 8 is 16. Square root of 16 is 4. Minus 1 is 3. So I can find an infinite number of functions to where I do the opposite. If I plug in 3 and get 8 here with x plus 5, I can do the opposite, plug in 8 and get 3. But then again, if I plug in, let's try doing where I can do a little bit of easy math here. I'll do square root of 2x minus 1. So if I plug in 45 and get 50, if I try to plug 50 into here, 50 times 2 is 100. The square root of 100 is 10. 10 minus 1 is 9. So I plugged in 50. Again, I did not get 45. I got 9. So now you're asking, okay, well, Coach Harf, if it's not just if I'm not just trying to randomly guess, like how do I figure out if two functions are inverses? Well, there's two methods where I can start with the original function and use the original function to find or calculate, whatever way you want to look at it, the inverse function. All right, so my two methods, we call the first one flip x and y. It's more algebraic. So we know f of x and y are interchangeable. We've learned that in the past. So I swap out f of x for y, flip x and y in my equation. So I flip them on either side of the equal sign. That's the only thing I flip. If y is just going to be by itself, if my x has a coefficient on it, or if I've got like x divided by 2, I don't bring the divided by 2 with it. I just flip x and y. Then I solve for y, use my algebra skills to solve for y. And then last thing is swap the y back out for the inverse function notation. So when I solve for y, that will be my inverse function, but I've still got to stick back on my inverse function notation on it. Do an undo method it's more verbal. It's more like a written list of steps. And again, you really kind of need to see it in action. But I take my original function. So I'm looking at my original function. I'm going to write out my steps to basically rebuild that function from scratch. I'm always going to start with x. Then I have to list out what all I'm doing to x. I end with, I don't have it written here, but I end with sticking the function notation on the end. So I'm just building the, the x plus 3, 2x minus 5 part. I'm just doing that first, and I stick the f of x on at the end. And then to get the inverse, I take my list of steps and basically do it in reverse order. So I should have flipped opposite operations in reverse order. I do my steps in reverse order, and then anywhere where I actually did an operation, add to, multiply by 5 or whatever, I do the opposite of that. And that's what lets me build the inverse function. So let's see a few examples of both of these in practice. All right, first one's very, very easy. I skipped over in class. I kind of want to skip over here because for doing undo especially, it doesn't really fully show, I don't believe, how the method works, since it's just really just doing one step, but we'll start with it. All right, so for the do and undo method, f of x equals x plus 4, I'm always starting with this x. So I'm going to write start. You'll have to forgive me, I got my little personal pad here at home. It's a little different in terms of how touchy it is from the one I have at school, so I might have to rewrite some stuff or erase and rewrite. So I start with x. I got the x in quotation marks. I'm actually going to put the x down here at the bottom. So now what I got to do, I have to figure out, I have to look at what all am I doing to x on this side of the equal sign. Again, we'll do f of x last. So everything that's over here, what am I doing to x? What operations am I performing on x in my function that is given to me? I'm not looking for the opposite yet. Some of y'all are jumping the gun on me in class. In the function that I'm given, what am I doing to x? The only thing I'm doing to x is subtracting 4. So I'm going to put subtract. Move this over a little bit. Let's see how that'll help a little bit. Subtract 4. So I subtract 4. That's the only thing I have to do. So then I'm going to end with, I'm putting in quotations. You don't necessarily have to, and I'm ending with my function notation, f of x. F of x equals x minus 4. All right, so to undo this, I'm doing my steps in reverse order. So the way it looks in practice is I did my steps in order here. So I'm going to come across from my last step and put my first step for undo. My first step is actually going to be start with x. So whether I'm doing do or undo, my first step is always going to be start with x. Again, I'm going to build it underneath it. So I'm going to start with my x. So up here at this last step, I'm not going to rewrite it. I'm not going to write it yet, not rewrite it. I'm not going to write it yet. Across from my original first step would be my last step, and with not f of x, but f negative 1 of x, the inverse notation. So anything in between should be any operation. Subtract 4, multiply by 6, take the square root, whatever. So I'm going to do the opposite of those. And because I'm going up, that's what lets me do them in reverse order. Again, kind of hard to see here since we only have one step. We'll be able to see it more on the next couple problems. I just got to one step. So instead of subtracting 4, I add 4. And then it's only one operation step that I'm doing. And so then I end with, again, I apologize for my, God, I'm sorry. End with, come on. End with f negative 1 of x, my inverse notation. F negative 1 of x equals x plus 4. All right, so for flip x and y, it's more algebraic. Okay, I'm going to start with my original function. I said I'm going to swap out f of x for y. We know they're interchangeable. You know, I've done enough problems. Obviously, I've done this enough where I can just cross it out here. Let me actually, again, don't write yet because I want you to do it more comfortable. But where I could just cross it out here, go ahead and put my y, and then show the next step, flipping it with x. So I could do both in one. If you need to do them separately, so again, before I show that, so at this point, I'm gonna leave a little gap so I can, if you don't want to do it this way, if you want to do it the other way, I'll show you that. So if you go ahead and do this, you flip y and x. Now I would have x over on the left side, y minus 4 on the right side. So if doing both steps at once is a little much, so f of x equals x minus 4, you could just cross this out and put the y underneath, then bring down x minus 4, and then show flipping them. So either way, you can do both the first two steps kind of at the same time, or you can break it up. But now I get to here, x equals y minus 4. So this is what I'm trying to get to. X equals something. So now I just got to solve for y. Now I just got to solve for y. It just, you know, like in a normal algebra problem, we're usually solving for x. So I got to get y by itself. So I got to get rid of the minus 4. So I add 4 to both sides. So this is where I want y'all to notice. Once I actually start doing my algebra, I added 4 to both sides. That was my one step I did here. So we're doing the same thing. You know, one's more algebraic, you know, one's kind of written out in steps more, but at the end of the day, we wind up still basically doing the same thing. All right, so I subtract 4 from both sides, or add 4 to both sides, excuse me. I'm a little too hard on that. That cancels out, leaves me y. Now I have x plus 4 on the left. So y equals x plus 4. I've gotten y by itself. So this is my inverse function, but I have to still write my inverse notation. So again, I can either just cross this out and do f negative 1 of x. If you want to just do that and leave it like that, I'm okay with it. If you want to, when you cross it out, so again, this is where I need y'all listening. If you just want to do this, if this is what you like, you can stop there. If you want to actually rewrite it so you can see the inverse function notation, you can cross it out, put it underneath, and then still do x plus 4 over here. And then even at this point, if you're used to your function notation being on the left and your the actual equation part of it being on the right, you can just flip what's on each side of the equal sign. And I'm not going to rewrite it underneath, but you can rewrite it to actually make it a little too far with that. But you can actually rewrite it and flip it to make it look like that. So you can just cross it out, put it next to it, cross it out, put the whole thing underneath it. And then even at this point, if you want to flip it, that's okay, because that's how it would look on multiple choice test. So that was pretty simple. Let's go to a two-step equation. All right, 2x plus 6. F of x equals 2x plus 6. So again, I'm going to start with x. Put it down here. Second step, and now my handwriting's getting a little small on this. Second step. So again, I'm looking at just the 2x plus 6. So now I have multiple things that I'm doing. Again, you can, when you get to this point, if you're doing do and undo, or when you're doing flip x and y before you start to actually do that, if you want to take a step back and say, okay, what am I doing in my original problem? And so when I get to what am I doing in my original function? So when I get to my inverse, I know what I have to do the opposite of. So if I look at this, the 2 in front of the x, that coefficient we know is multiplying. All right, so I'm multiplying by 2 and I'm adding 6. So those are going to be the 2 steps. We'll figure out the order in a second I have to do for do. And then the opposite of those, dividing by 2 and subtracting 6, those steps will have to be an undo, and ultimately those are going to be the operations I do over here algebraically when I am trying to solve over here. But doing my do, rebuilding this, multiplying by 2, adding 6. We basically want to start with whatever is touching this and then build out, the next, whatever's closest would be my next step, whatever's as you continue to build out. So whatever's touching it would go first, and I kind of build out from there. If I happen to have a denominator, which we'll see on the next problem, that's going to be the last step. So the 2's touching it, that's closest. So we're multiplying by 2. So I'm put multiply by 2. And then third step is add 6. So I'll stick the plus 6. And then end with, sorry guys, it's being so touchy. End with, I'm not even putting the parentheses or the quotation marks at that point. And with f of x. So f of x, oh God, I'm sorry, y'all. F of x equals 2x plus 6. Okay. If I had done the steps in reverse order, I'm just going to show it here in the middle. So if I had done add 6 and then multiply by 2. If I started with x, if I did add 6 first, I would have done that. And then when I multiplied by 2, whatever next step you do, you have to do the whole thing. So it would not just be sticking the 2 in front of x. I would have had to multiply this whole thing by 2. So these are different. This would, if I actually distributed that would give me 2x plus 12, which is of course different from 2x plus 6. So that's why I can't do that. All right. So undo. I'm going to start. Gosh, I'm sorry. I'm going to start with x. Hold on, y'all. Give me just a sec. I'm sorry. Can you go out? All right, I apologize for that. I had to let the dog out. So I start with x, and now we can really see it. So again, this last step is going to be end with f negative 1 of x. And now here in the middle, my 2 steps, multiply by 2, add 6. So I'm going to have to divide by 2 and subtract 6. But now since I'm going up, again, our first step originally was multiply by 2. So it's not going to be divide by 2 because I got to do it in reverse order. So it's actually going to be subtract 6. And I apologize for the handwriting with my pad I have at home. So minus 6. And then, I'm sorry, y'all. I'm going to take up more time on this video, just having to go back and erase stuff. Divide by 2. So again, I got to divide the whole thing by 2, not just x over 2. The whole thing over 2. And then end with f negative 1 of x. So f negative 1 of x equals x minus 6 divided by 2. All right, so for flipping x and y, again, I already had it written, so I'll cross it out. I'm going to put it over here on the side because I might need 2 columns. Y equals 2x plus 6. Flip x and y, and this is what I was talking about on the explanation slide. I'm only flipping x and y. I'm not taking the 2 with it. So x comes over here, and then I got 2y plus 6. So now I'm going to solve for y. Again, if we're applying our algebra principles, we know I got to get 2y by itself. So I got to get whatever has the y in it by itself, and then deal with whatever's attached to it. So I got to get rid of the 6 first. So I'm going to subtract 6. Again, if I look over here, that was my first step. So it matches up. So I'm going to have 2y, x minus 6. Now to get y by itself, I divide by 2, which again was the second step. So it matches up. So I've got x minus 6 divided by 2 equals y. And again, if you just want to cross it out and put f negative 1 of x, you can do that. If you want to cross this out and rewrite the whole thing, you can do that. And then even at this point, if you want to flip each side of the equal sign that it's on to make it look like that, you can do that too. I got f negative 1 of x equals x minus 6 divided by 2. All right, last example I'm going to have on this video. 3x minus 4 divided by 5. I might have to scroll down a little bit here for my steps down here. 3x minus 4 divided by 5. All right, so I'm starting with x. I'm going to go ahead and I might have to scroll up and down a little bit, but I want to make sure I have it. So I'm going to start with x. So I come back up. Now I got to say, well, what am I doing next? Multiplying by 3, subtracting 4, dividing by 5. So again, we're basically building outward. And whatever's touching x and then whatever's in the numerator with it, again, from what I give y'all, I could get a little more fancy in the denominator, but you're usually just going to see a number down here. So if I'm dividing by anything, whatever the denominator, that'll be last. So I'm going to start with multiply by 3. So I'm going to stick to 3. And then subtract 4. So now I'm going to stick that. And then divide. Divide by 5. Drag it down. And then my last step is going to be end, not ed. End with f of x. And again, y'all seen I've just gotten away from doing the quotation marks, so that's fine. So f of x equals 3x minus 4 divided by 5. So now for doing undo, again, I'm going to start with x. Gosh, this thing is so touchy. So now I got 3 steps. Multiply by 3, subtract 4, divide by 5, and I'm going to do them all in reverse order. So I've got to multiply by 5. Golly. I'm going to add 4 Think about right a little slower, it helps. Add 4. That's not helping as well. Divide by 3, so divide the whole thing by 3. And then end with f negative 1 of x. So 3x minus 4 divided by 5 is turned into 5x plus 4 divided by 3. All right, so now flip x and y. And I'll write it over a little bit, kind of do 2 columns with it. So cross it out. Y equals 3x minus 4 divided by 5. Flip x and y. So flip it. Now, again, solving for y. So now if I'm looking, again, I got to get to my y. So before I get to the numerator, I have to get rid of the denominator because, if anybody wants to say, add 4 first, which I'll have to remember this is really 3y divided by 5 minus 4 fifths. So I can't add 4. I would really have to technically be adding 4 fifths. So if we just get rid of the 5 first to kind of open up the numerator, it makes it easier. So I'm going to multiply by 5. That cancels out. All right, so it gives me 5x equals 3y minus 4. Again, if I look, what was the first step I did? Multiply by 5, multiply by 5. Add 4 to both sides. All right, I'm going to move it up here now. So I add 4 to both sides. Leaves me 3y on the right. 5x plus 4 on the left. Again, add 4 was my next step going up. And then divide by 3. That was the third step going up. So I'm left with y by itself on the right. 5x plus 4 divided by 3 on the left. And again, you can replace that. I'll rewrite it. F negative 1 of x equals 5x plus 4 divided by 3. All right, so there's 3 relatively easy examples. Like I said, I'm going to do another example video, or I'll just, I know I said I was going to do 2, but in terms of time, since I didn't do this till today, I might just post the one from last year, maybe just trim it somewhat. I'm going to have to look at it, but I'm going to go ahead and get this one up, get your assignment up, send y'all a message and remind. Obviously, I've already done this by the time I get this video up. So hopefully y'all can at least start with this, and I'll have the assignment up as well. All right, so make sure you watch this, get your homework done in preparation for the unit test this week that we're taking before Thanksgiving break, and get prepared. See you guys in class.